Greetings everyone, and welcome to the demonstration of my Hong Kong Tramway Simulator, built entirely within the new Unity 6 engine. My objective for this project was to create a highly accurate physics-informed digital twin of Hong Kong's iconic Ding Ding tramway system. As a software engineer rather than a 3D modeler, I want to focus heavily on complex system architecture and mechanics. To maximize efficiency and ensure I didn't waste valuable production time on massive asset creation, I utilized high-quality pre-existing assets, specifically a detailed post-war double decker tram model and a highly optimized tile-based 3D photogrammetric map of Hong Kong. As you can see, I have created a map from Kennedy Town to Western Market. As you can see, there's a lot of details with this map. This strategic decision allowed me to dive straight into mastering Unity 6 advanced technical feature sets. Let's look at the core mechanics. To achieve the tracking stability, I moved away from unpredictable rigid body mesh collisions. Instead, I engineered a deterministic kinematic track system using the new Unity Spice API. The script samples two independent parametric uh, points along the path. As you can see, I have created a spine for the tram to follow for the tram to move. You can see there's a yellow line here, and then it will go through to the Western Market. As you can see, there's a yellow line here and the tram can follow this line to run. The script samples this advanced tram controller script samples two independent parametric points along the path, representing the front and the rear wheel bogies, and encodes the vehicle transform exactly to their midpoint. By implementing a boundary limiting MFF claim zero algorithm, I successfully resolved the critical terminal overflow expectation where the vehicle will flip orientations at the boundaries. Additionally, I took advantage of Unity 6 low-level spline data to extract curvature vectors. By projecting these vectors into local coordinates using a dot product, the system dynamically calculates centrifugal forces. As you can see, there's a mass speed acceleration, neutral and the brake force here, driving a smooth weight influence set axis rolling. This replicates a top-heavy kinetic momentum that makes operating a real double-decker tram uniquely challenging. Another key milestone was implementing an integrated multi-decker perspective and cockpit system. So I will show you the system. So although there's still some bugs with the tram simulator, as you can see in the game, you can see the tram is under the map. But however, when I press the W button, it will back to the Kinetic Town, and you can resume to continue the tram simulator. So by pressing the V key, you can change players can cycle seamlessly through three distant viewpoints. A comprehensive external tracking view, so like this, an immersive view, uh, a first-person driver's cabin view, as you can see, uh, and an immersive passenger upper deck view. As you can see the upper deck view. To achieve this smoothly without manual factor interpolation, I engineered a responsive parenting framework that shifts camera targets dynamically. Furthermore, I tried input controller directly to the cabin's visual components as you apply photo using the vertical axis as a specialized map script drives the localized rotation matrix, animating the physical photo handle in perfect synchronization with the tram's near frequency. As you can see, when I start to press F, not F, but W, you can see the tram start moving, and you can see there's a lot of you can see you can see a lot of scenery of the tramway. Now I'm still pushing the W key, and you can see tram is still moving. But when I release the W key, the key W, the tram will still moving, and you will literally deceleration to reduce speed in order to create a realistic experience. And as again, I'm now holding a W key and still moving. Also, you can when I press the S, will the tram will stop it, will stop. When I press the W key again, the tram will start moving again. But when I press the S, and the tram will stop smoothly. Also, when you press S longer, the tram can be backwards. As you can see, there's some mechanicals here, and you can see the when you press S, the tram won't do a complete stop. Also, you can see there's a lot of scenery in the Kennedy Town. Although there's still some terrain I have to fix. For example, this tram station, I will I will s- I will fix them in the future update. And also, you can also press F for the ding ding sound effect. As you can see, when I press the F, you can hear a tram ding ding sound effect. There's a although this 3D model map is the best, however, this also help me save the time with the 3D model map. However, there are some rails that not align with the tram, and this will be told after the demo presentation. As you can see, the scenery is so realistic that this will make it more and more. It feels like you are really driving a tram in Hong Kong. So there's another stop. So we'll stay here for a while. Okay. So let's go to the another stop. So there's another stop. We will stop here for a while. Okay. So after making stop, I will resume to continue the journey. Although I have pressed the W, the lim I have set the limit speed, so it won't be overspeed. Okay, so there's another stop, and we'll stop here. After I make a stop, I will continue the journey. So there's another stop where we will make a stop here. After the stop, we will continue. So we are here at the another stop. We will make a stop here. Okay, let's go to the another stop. Also, you can feel the upper deck and the third person view. So we almost arrive at another stop, so we'll stop here. Let's stop. After this stop, we go to the next stop. Oh, sorry, this is real the tram stop. That one is not. So this is the stop. After that, we go to another stop. So we will soon arrive at another stop. So I will make here for a stop. After we stop, we will go to the terminus. there's some issues that I have to fix. Since as you can see, there's the train was flying through, and there's some issue I have to fix soon. And, okay, let's stop. Okay, and this is all the demo of from Kennedy Town to Western Market, and also let's talk about the. Now I want to address a major technical shortcoming and share some honest self-criticism regarding to my project timeline. And looking at my initial scope, I plan to deliver a fully functional dynamic AI present traf- traffic system that will react to the tram acoustic signaling. However, as you can see there, I have set the spawn point and the target form for the AI president jaywalking. However, during the integration phase, I ran into a server access scaling mismatch where the imported rail geometry did not conform to the roadmaps. As you can see, the rails is under the map, or maybe just the scale is have some problems with this. As you can see, the rail was broken. In trying to force the global scale override on the entire map, the massive transform hybrid corrupted the engine serialization and caused a catastrophic editor crash that could not be undone. I had to completely recreate a recipe from scratch to solve the issue. I collaborate closely with a peer who assists as a model designer. Together, we manually adjust the y-axis coordinates of the track nodes to snap directly to the S how meshes and configure the track as a reverse loop route to fix inverted model axis. Most importantly, I realized that the cosmetic rails have zero physical impact on the trans mathematical fiction loops. This allowed me to decouple the visual rails from the invisible spine-like paths. While this solved the issue perfectly, diagnostic debugging and rebuilding this system consumed another month of continuous development, which unfortunately starved the AI subsystem of the time required for full integration. In conclusion, despite the scheduling challenges, this project has been an invaluable learning experience. I have mastered the advanced tracking capabilities of Unity 6, implemented a cross-platform FPS access pipeline from Blender, and successfully built a stable, highly augmented mass transit loop. Moving forward, the primary lesson I will carry into future engineering projects is the absolute necessity of maintaining robust automated version control backups before executing disruptive scene scale overrides. Given more development time, my absolute priority will be reintegrate my completed AI state switch to fully activate the President hazards. That's all the game demo.